Welcome to Study Loop.
So we are given with a spring mass 1 kg, spring constant k equals to 100 and damping coefficient 10, 15, 20, 25 and 30. Initial condition is the spring is stressed by 0.1 meter at time t equals to 0. Okay, and we need to graph for different values of c, and we have to mention what type of damping for a given damping coefficient it gives. Okay, so for such kind of question we have general differential equation is m r square plus cr plus k equals to 0, and if we solve this we have r as minus c plus minus root of c square minus 4mk over 2m, and for this, because of this root value we get three conditions, that is if c square minus 4mk is greater than 0 it is overdamp or overdamping. If c square minus 4mk is equals to 0 it is critically or critical damping, and if c square minus 4mk is less than 0 it is underdamping. Okay, so we need to check in which categories for these values of c this function falls. Okay, so let's calculate. For we know the value of m and k, so let me just solve here. For m equals to 1, k is 100, and we have to just change the value of c. So first it is 10, so we'll have 10 square minus 4 times 1 time 100, which is 100 minus 400, so less than 0, so it is underdamp. Okay, for second, that is c equals to 15, we have 15 square minus 400, since this value will remain same, so 15 square is 225 minus 400, which is again less than 0, so it gives us underdamp. Next is for c equals to, next value is 20, so for 20 we have 20 square minus 400, which is 400 minus 400, which is 0, so this is critical damping, so I'll write just critical. Okay, for c equals to 25, this becomes 25 square minus 400, which is 625 minus 400 greater than 0, so it is overdamp. Okay, and the next value again we have 30 square, so for c equals to 30, this is 30 square minus 400, which is 900 minus 400 greater than 0, so again it is overdamp. Okay, great. So we know the type of damping, and here we can plot the graph for each one. So let this be time t and this be x. Okay, so I'll draw for, we have 5, so for 10, okay, it is underdamp, so we know for underdamp it is fluctuating curve. So if we draw here, let's say we'll have like this. Similarly for next, it is 15, so it increasing, so the curve decrement will increase. Okay, let's say for this we had curve like this, so for next one we'll have more steeper one. Okay, so let's say it starts here, and it comes faster. Next, so again we have 2, so this is for c equals to 15, and the previous one was c equals to 10. For c equals to 20 we have critical damping, right? So let's draw for critical damping. So we know for critical damping it's a, let's say it starts from here only, it will come down and it will settle quickly. Okay, so this is for c equals to 20. Now over damping, so let's take another color for over damping. So over damping, it come faster without fluctuating, so it will come directly down. So this is c equals to 25, and for c equals to 30 it will damp faster than the c equals to 25. So let me take another color, and you can make it die more quick here. Okay, so this is c equals to 30. So this is how the graph will look for different c's, and these are the type of damping for different c's. Thank you.